The most important aspect in building a sense-blended digital learning software is the assignment of colors to content. Color is a core aspect of our lives, yet is so omnipotent we take it for granted. But as we examine the phenomenon more deeply, colors have long held profound meaning dating back to antiquity. In utilizing color to distinguish aspects of core curricular components, we may stop to consider how and why people attach so much metaphoric meaning to common colors we see and use. First, we must parcel out two components that shape the color meaning paradigm: nature and nurture. In examining the phenomenon of synesthesia, the automatic blending of senses, author Julia Simner, along with other neurological experts in the Oxford Handbook on Synesthesia, chronicle many examples of patterns of what influences people to make color meaning connections and looks for cross-cultural consistencies. They find that among color-chrome synesthesia, the most common form, that people associate colors with letters and numbers. A in English speaking language and Romance languages tends to be represented in red. This is presumably because A is for apple and begins the alphabet, hence the color of many apples in the beginning of the rainbow. There are certain universal patterns in color meaning association, such as yellow. The color of sunlight tends to possess bright emotional connotation since everyone sees the sun. However, that stated, some cultures can have specific meanings. In Western culture, for example, red tends to be connotated with blood, hence strong passion, both joyous and fearful. In Eastern cultures like China, on the other hand, red resembles fortune and longevity. Therefore, in selecting color content connections, such varying aspects of association need to be taken into account. Fortunately, software such as this can be tailored and adjusted with menu bar options to customize. The important goal is not which colors are used, but that color can be associated with the form, function, pattern of core content. No matter who we are and where we're from, different colors always conjure intense feeling of various sorts. This can be converted into corresponding connections of material, for example, when distinguishing consonants and vowels, first being opened and the second being closed sounds, the first perhaps being brighter and the latter darker. In math, one may distinguish odd and even numbers, multiples, or prime numbers differently. So this pattern can easily stipulate the different patterns and functions within mathematical processes. We can also use colors to connotate placement value, highlighting the basic concepts of decimal mathematics. This process is especially important as it enables each teacher or instructor to parcel out the bridge between the two main components of learning, being the procedural or rule-based associated with the left neurohemisphere and the more abstract conceptual constructs of the right one. Combining color coding and dimensioning can clarify through visualization the process of tabulation and that of functional relations. Another growing field involving color theory is the synesthesia of taste to color. The culinary industry is innovating ways to associate and influence how people taste and experience food based on their color connections, some which can be naturally derived and some man-made. We know that Skittles has long used color associations, again, associating roughly with fruit flavors, but partly man-made. Color gradation is another tool that can be utilized by turning a color spectrum utilizing two primary colors and their ratios of secondary combination. We can show the nuance of gradation of value between two or more phenomenon bleeding into each other. This brings us to our final topic, which are the question, are colors quantities or qualities? We intimate them to be the latter, for we associate them as experience or qualia. This may be true, but colors also possess quantitative properties as well. We know the spectrum of light falls to its own unique measure, and for a computer, data of quality are put in binary structures with ratios such as the RBG scale, where three different colors can combine to hundreds or thousands of combinations to gradations of color. Hence, color can be numeric, and yet it also experiential. Understanding these associations can help us delineate the core components of learning.